everyone, my name is Adam Simpson and you're watching my YouTube channel, Adam M.A. Simpson. This is part 2 of my interview with Dr. Carlotta A. Please enjoy and stay until the end. Awesome, so let's pivot into the second half of this interview, which is about how your teaching and research impacts the greater society. So your research focuses on engaging science and engineering students in multidisciplinary projects using robotics and developing programs to increase the recruitment and retention of women and minorities in engineering. Please tell us about one of the most rewarding projects and outcomes this far in your career.
So, I can try to, pare it down to one, but you asked me for a lot.
Of course, yeah.
So I started the Rosebud program with my colleague, Dr. Deborah Walter, in 2009, and Rosebud stands for Rose Building Undergraduate Diversity. I am at a small engineering school with only about 2,000 students, and it only started admitting women in 1995, so it was all male up until 1995. And because it's Indiana and it's kind of the demographic of Indiana, we're about 70% male, and mostly that's white male Midwest. And so my colleague and I noticed that some years there were no women and few students of color graduating in electrical and computer engineering.
Wow.
So we applied for and received a National Science Foundation STEM grant in order to create a scholarship, professional development, and networking program. And that's what we called Rosebud. The funding for NSF ran out many, many years ago.
Yeah.
But the program has proven to be so successful that it is now sustained by the university.
Wow.
And it has actually grown to include computer science and software engineering, because those are the two departments that seem to struggle the most with recruiting and retaining women. And then once you retain, also developing. So our program requires a GPA. They also have to attend networking and leadership events, including going to Center for Diversity events, right? Because each one has to teach one and reach one and give back. So one of the things I'm most proud of is that the university has reached out to me and my colleague and said, just because of the existence of our program, the enrollment of women grew to between 20 and 25%, when it used to be much smaller than that. And the number of Black and Brown students who chose to come to the school has grown because of that. The other thing I am most proud of, because I don't follow directions, is around the same time, I worked with another set of colleagues to create the multidisciplinary minor in robotics. So this is a robotics minor that students in multiple disciplines can earn, including the ones that I listed earlier. And the school has also told us that just because of the existence of this program, the number of students who chose to come here has grown. Because some of them still want to be an electrical engineer or a mechanical engineer, but the fact that they can do that and know a little bit about controls, programming, software, which you can get with a minor in robotics, because you have to cross those disciplinary lines, means that we're now developing a more well-rounded engineer that we're sending out into the world.
Of course. I
tell my students, you're not going to go anywhere and work with a bunch of cubicles with a bunch of mechanical engineers. You need to be able to speak a little bit of the electrical engineer's language, the computer scientist language. You create this great mechanical device. How do you power it? How do you turn it on? You need to know something about electricity and motors and sensors and controls. So those are my two proudest moments. So I use those programs to do research, but I also use it for service and for teaching. And this is actually where the name for my company comes from, Nowhere STEMinist. It's the way that I encapsulate all that stuff together. If I'm a roboticist, I can use my robotics to do service, to draw more people into robotics. I teach robotics to teach multiple disciplines about the intersections of all of their disciplines together. I also use it for my research. So my research students don't just come from electrical engineering. I have mechanical engineering students as research students, computer science and software engineering students, and they're working on projects related to human-robot interaction And it's in the title because I don't want you doing anything where you're not considering the human as part of that machine.
Mm-hmm. That's tying into what you're doing in Black in Robotics too.
Absolutely.
Yeah.
Absolutely.
I love that. And throughout your, many successes with this program, how can we engage undergraduate students in academia, particularly women and minority students, through, having these programs to encourage them to, study electrical engineering or, multidisciplinary software, computer, electrical engineering programs?
I think it is extremely important that you show them the human side of what they have to do. Mm-hmm. One of the largest disciplines for women is biomedical engineering and civil engineering. And when you talk to those students, it's because they say, well, I could easily see how those types of engineers benefit society and help people. Oh. And you have to tell them all types of engineers benefit society and help people. Mm-hmm. So the fact that they're not able to easily see it and embrace it means something needs to be changed about the way these are marketing. Engineering has a marketing problem. It has a marketing problem because we don't have enough engineers of color and women on TV, on social media, on YouTube channels, on TikTok, in the movies, on the big screen and little screen. So this is why I do what I do to change the face of STEM in the profession. This is why I have all these social media accounts. This is why I make Black STEM gifts. This is why I do all of those things so that when you're talking to students about engineering, they're not picturing MacGyver, Dilbert, Sheldon, and they're not picturing a Black person or a woman, right? Mm-hmm. So that's how we get them, is show them, how is this relevant to me in my life? How can I use this to help me and my family? Mm-hmm. And how can I show you that you look like an engineer where you are right now?
Mm-hmm. That's awesome. And can you demonstrate to us how you approach using robotics to illustrate the intersectionality between various disciplines? Well, you kind of already stated this, but can you talk some more about what a research project looks like with your, multidisciplinary students in your research? How does that go?
One of the projects they're doing right now is I try to tie everything back to education. So if they're doing research on some platform and we get something interesting, I'm going to roll it into class, because that's one thing students talk about a lot as well, is that those who can't teach. They think professors are professors because they couldn't cut it in the real world.
I hate when people think that, because it just means they don't know what we do.
Don't know what we do. Yeah. The assumption is you're here in the classroom because you couldn't make it. So I always tell my students, I worked as an engineer. I chose to come back to teach you for crumb snatches. I chose to do this. But so one thing we're doing right now is I have my students have several mobile robots, and they all have different sensors on them or different ways of communicating wirelessly. I want to show how you could make a robot team work together where they recognize different parts of the team can do different things well. For example, one robot could have a camera, one robot could have a gripper, one robot could be really good at Bluetooth communication with the rest of the team. So can you design this system or add a sensor suite to it so that they could come together to achieve a mission? And then let's say we simulate search and rescue. And let's say the search and rescue is going to, they had search and rescue robots at the World Trade Center at 9/11. They had search and rescue robots down in Florida recently when that condo fell, because it's not safe for first responders and firemen to be in the rubble all the time. But you can send a robot in there, but the robot or the person operating the robot may not be as aware of what it's looking at. It may not know, is that a rock? Is that a leg? Is that pants? So you have to show how a first responder who does not have the technical skill to use a robot can work with a roboticist who may not have the technical skill to understand search and rescue. How do you bring different members of a team together to use a technology at a level where they can both understand it? This is what my PhD was on, human-robot interfaces. How can you remotely control a robot where the people controlling it have different skill sets, all valued members of the team and all important, And also the robot, understanding the robot's limitations and what it can and cannot do, right? Robots are great at repetitive, well-defined tasks. Robots may not always be so great at perception. Perception being taking sensor data, trying to figure out what's going on in the world and making intelligent decisions. That's where you may want to have that remote person do that for you. So what my students are working on is designing human-robot interfaces that will have an intuitive design so that a novice user could use them, but also to help them to understand situational awareness and usability and what's going on remotely with the robot. Is it actually advancing the task? Is it achieving it? Is it able to do what you want it to do? So this requires a lot of different people, right? Because
definitely.
I said controls, that's electrical and mechanical engineers. I said software, designing the interface, that's software engineers, computer scientists. The wireless communication would be engineers as well. So then also, if you're looking at the human aspects of fatigue, mental fatigue, for maybe looking at an interface for a long time, that could be somebody in social psychology. Mentally, how is it affecting this person remotely driving a robot for 8 hours trying to find survivors?
Exactly.
So coming up with these kind of tasks, I can show you how all these disciplines have to come together to make that happen. But what I would do is once we get this to a point that I'm happy with, I then would deploy it in my class and let my students use it as a final project. So they're now considering all of these real world challenges just as an assignment. So that's now giving them something. You can say, no, this is really happening. You're not saying this, your professor making up things that don't really happen in the real world.
I love that. You know, it bringing in what researchers do into the classroom, so students have a taste of you know, academia and, you know, what you did to get where you are, which I think is important. So now getting into the final section of the interview, which is my favorite question, and it's about misconceptions of the professoriate and, you know, things that you would like to dispel. I also want to kind of have a focus for, you know, like a teaching focused institution, because, you know, I don't think a lot of people may know why someone would prefer this track. So I'd love for you to speak on that.
Okay. Let's do misconceptions first. Misconceptions, and this is actually true for whether you're at a teaching focus or an R1 or R2 school. Professors don't work in the summertime. That's a lie from the pits. We work year round. Professors work more than a 40-hour-a-week job because a lot of times during the day we're holding meetings, we're doing service, we're doing teaching, we're doing research. So that leaves nighttime for preparing for class, or nighttime for writing grants or writing papers or reading or writing recommendation letters. So one of the biggest misconceptions is that professors have a cush job because we only work 9 months out the year and people only see us working when we're in class. The amount of time I spend outside of class, getting ready for class and other things, is way more than that 4 to 6 hours that I'm in class every week. Another misconception I see a lot on social media is that professors don't care. They're about weeding students out with weed out courses. All of that is the exact opposite of how I define myself as an academic, which is a great segue as to why I'm at a teaching school. I'm not saying that all engineering schools are about numbers and weeding out and all of that, but I just think that if you're at an R1 or R2, you're going to focus your energies on what you are assessed and promoted on. And if all you're hearing from the school is you get promoted based upon the number of PhDs and master students you graduate, the number of grant dollars you bring in, the number of papers you publish, that's where your focus is going to go. And if teaching and service are way down on the totem pole, then that's where you're going to get professors who appear not to care about students. It's not that they don't care, it's just that they care more about bills and retaining and taking care of their family. So therefore, teaching and service are going to come at the back of the line. I did not like that because that's not what I value, right? You inspect what you expect, and that's what you get. And that's why professors at those schools operate the way that they do. I wanted to be at a school where I could do what I value and think is important, and it would be rewarded. and that was a teaching school. So my school, we probably teach double or triple the course load that professors at an R1
definitely.
do. So 100%, I do not advocate coming to a teaching school if you do not love teaching, you do not love interacting with students. I am an introvert at heart, but I love teaching. So because of that, this is a great place for me. But for example, I teach 7 to 8 classes a year. Professors at an R1 may teach 1 or 2, and some professors with a lot of research dollars may buy out of all of their teaching. Right? So all they do is go to the research lab. So that's one thing about a teaching school. Another thing is you're going to do a lot more service. And then as women and people of color, you're going to do double you're going to do double anyway, because that tax and that invisible labor are real, but also you just have to be prepared. So like at my school, we do the academic advising for our students. We don't have other people do that. I have a personal relationship with my students. None of our classes have over 30 students. If you're at a larger school, you may be in a lecture hall with 200, where you have a teaching assistant who does all of your office hours. At my school, we do our own office hours. PhDs teach all the courses. And if we do have teaching assistants, they may grade homework, but our teaching assistants do not do lectures and they do not grade the exams. So your workload is going to be extensively higher, which means your expectations for research and all of those types of things also have to pair. So as the 3 tenets, research, service, and teaching, at a teaching school, they're probably more even as opposed to at a R1. Correct. And that is because I now have to do those other things. So I think it's important now that I'm a full professor, I have figured out a way to intersect those things together so that I'm working smarter and not harder. Ways I do that is integrating my research into my teaching into my service. And they kind of all marry and inform each other so that I do not feel like I'm having to steal from Peter to pay Paul. They all work together.
Yes. I've heard the same, because service is important to me. I love the advising aspect of academia. And I got the advice to find a way to make a paper out of it.
That is so true. That is so true.
I know that I have plans to try to publish in an engineering education journal, because that service is important to me, and I think that I can hopefully being considered for tenure, I can have that as part of my portfolio.
And figuring out ways to marry the numerous service requests you're going to get with what will advance your career. As cool as some things are, you're going to have to put them off if they're not going to help to retain you and promote you. For example, I started being asked to be the NASB advisor the moment I arrived on campus, but I turned them down until I got tenure.
Exactly.
Being the only Black woman engineering professor on campus, of course they wanted me to be the NASB advisor. But I knew that was not going to be as high of a priority as some of the other things I needed to do to be retained. Once I got tenure, I don't have a problem being the NASB advisor. I love to do it. But before that, I wasn't going to be here to be their NASB advisor if I didn't get those papers done, get that research done, et cetera. So you got to have these long-term and short-term goals all the way in the back of your mind and start balancing them when people ask you to do things, including, can I get a paper out of this, right? That also has to be part of it.
Yeah. Awesome. And I think you have done, I can tell you do this a lot, because everything just came out in such a beautiful way, and I know it's gonna be so easy for me to edit this, because it's just everything you said was so meaningful and useful and educational. And the
other thing you have to think about is, even if we get past the podcast that I do, being a professor, even if you're a naturally shy person, you're going to become very adept at asking questions coming at you from a lot of different directions. Think about students and what they're doing when you're teaching, coming at you from a lot of different directions, and being able to think on your feet, right? So I know you had emailed me a couple of times before today, and you said something like, "Are you going to be ready?" Here's the question. Baby, I was born ready. when you stay ready, you don't have to get ready.
Get ready, yeah.
So and I think that's the difference, because I've had some people interview me and they said, well, I have to do that because you're also an engineer, and because we need to break the engineering stereotype. And some engineers are not very personable, they're not warm, they're not friendly, they can't think on their feet, they're kind of dry, they're kind of blah. People assume because I'm also an engineer, I have to do that. But that's what I like to tell people. I'm not your mama's engineer. I'm not your standard engineer. But I know that's why people do that a lot, because they don't know what they're going to get.
Yeah.
And they think they may get someone who can't look them in the eye and is going to talk to their shoes. But you have to remember, I was going to be a teacher first. So I got a little bit of that in me too. But yeah, we need to break that stereotype. All engineers are not like that.
I mean, yeah, we do need to break that stereotype. And this is something that has been, on my mind, because I'm in civil and environmental engineering. And as someone focused on the environmental side, our discipline has become politicized. And unfortunately, academics don't like to get into the political aspects of things because of fear of seeming biased. But, I think that it's important to speak out and be vocal, because it's already politicized. So we have nothing to lose at that point. And yeah, I just think, changing that stereotype of the engineer that's afraid to speak and express themselves is so important.
Yeah, absolutely. And to be honest, students, and I even probably used to think the same way. I pick math and science because I'm not really into those soft skills, what we call professional skills, public speaking, being able to write a technical report, technical writing. So I spend a lot of time as an engineering professor trying to get students to understand that stuff is equally as important. Stop throwing away your humanities, social sciences, and art courses, because all of that makes you a better engineer. Being able to talk to people about your design, being able to communicate them if somebody wants to give you money to build it. So stop throwing away that, thinking that if it's not math, physics, calculus, chemistry, etc., it's not equally as important. It is. Being able to connect with people is how you work the best as an engineer.
Yes, it is. Thank you for that. Thank you for legitimizing all of these things that I've been thinking for a long time. So yeah, it's nice
Thank you for having me. This was fun.
Yes, it was. It really was. Okay. So thank you. And until next time, thank you so much for being with
welcome.
me
Good
today.
luck with your podcast.
Yes.
No, it's going to be great.
Yes. All right. Bye.
Bye.
Thank you for watching the completion of this episode with Dr. Carlotta Berry. Stay tuned for more episodes to come in the future, and please like and subscribe. See you.